Alice and Bello contributed to the cost of starting a new business. A ratio of Alice's contribution to Bello's contribution was 3 to 8. If the cost of starting the new business was 9,240, what was Bello's contribution to this starting cost? So we have, let's see here, A over B, Alice and Bello is 3 over 8. So that basically means 3 parts for Alice and 8 parts for Bello. So in total, there's 11 parts, right? So what you do is just take the 9,240 and divide by those 11 parts. And that actually comes out to 840. And then you distribute them among Alice and Bello. So what do they want? They want Bello. So Bello is 8 parts. So it'd be 8 times 840, because each part is 840. And 8 times 840 is 6720. And you can do the same for Alice by using 3 times the 840. Alice and Bello divided up all the profits in the first year of the business in the same ratio, 3 to 8. Alice's share of the first year's total profit was 1,881. What was the total profit of the business for the first year? Okay, so total profit for Alice. Okay, I got it. So basically, same thing, 3x is 1,881, and 8x is for Bello, I guess, right? Okay, so that's Bello and this is Alice. Okay, so first let's figure out what's x. 1,881 divided by 3, so that's going to be 627. And therefore 8x would be 8 times 627, and that is 5016. So what do they want? They want the total profit. Okay, so total profit's going to be this and this, I believe. Is that right? Yeah, 1,881 plus 5016, and that's going to be 6897. Okay. In the second year, the business was changed so that the share of what that year's profits for Alice and Bello was in the ratio 3 to 8 plus x. If the profit for the second year was 6400 and Bello's share of the profit was 5440, determine the value of x. So now the ratio is 3 over 8 plus x. And this time, let's see here. Bello is 5440. Okay, 5440. And then the total is 640. So I guess for Alice, it would just be the total minus what Bello got. Okay, I'm pretty sure that's the math. Okay, so now we just have to solve this for x. It shouldn't be that hard. So that's 960, and that's 5440. Cross multiply, and you get 16320, and here we get 7680 plus 960x. And then bring that to the other side, and you get 8640, and that's 960x, and then therefore x would be 9. And that is the solution. In the diagram shown, the line L1 has the equation y is equal to 3 over 2x plus k, where k is greater than 0. And L1 intersects the y-axis at P. A line L2 is drawn through P perpendicular to L1 and intersects the x-axis at Q. The line L3 is drawn through Q and parallel to L1 and intersects the y-axis at R. What is the slope of L2? Okay, so L1 has the equation y is equal to 3 over 2x plus k. And L2 is perpendicular, right? So if it's perpendicular, its slope will be in the negative reciprocal. A negative reciprocal. Now, the equation of a line is in the form y is equal to mx plus b, right? Where m is the slope. So in this case, the slope of L1 is 3 over 2. The negative reciprocal of 3 over 2 is minus 2 over 3. And I think that's it. Yeah. Part B, written in terms of k, what is the x-coordinate of the point Q? All right, so the first thing I have to do is, I think I'm working with line 2, right? Yeah. Okay, so the line 2 is, we just figured out the slope is minus 2 over 3, but we're not sure what b is though. Okay. All right, so, well, the point that they want Q crosses the x-axis, right? So that means at this point Q, the y, it's something, right? Something 0. The y coordinate is 0 since it's on the x-axis. So what we can do is just put 0 there, and that should allow us to solve this. Let me just see. Okay, we got this k here. I don't know why I keep putting b, because we already got that k. Okay, I got it. Oh, but I actually do need to figure this out though, because I'm not sure that what this will be. Okay, so, well, we know one thing for sure, that they have a intersection point, because they have this intersection point P, so we can let them equal to each other. So 3 over 2x plus k, which is the line 1, has an intersection point with line 2, so they would eventually be equal at some point. So it would be minus 2 over 3 x plus b. Yeah, like that. Okay. And this happens when the x-coordinate is 0, right? At point P, the x-coordinate is 0. So if you put x equals 0 into this equation, you just get k equals b. So that means that this equation actually, or this equation I should say, is actually minus 2 over 3x plus k, since k equals b. So therefore this equation is going to be 0 is minus 2 over 3x plus k. Okay, I got it. So that means 2 over 3x is equal to k, and therefore x is equal to 3 over 2k. Yep, that pretty much does it. All right, so now the area of PQR is 351. Determine the value of k. So PQR, where is PQR here? PQR, okay, I got it. This guy here. Okay, so that they're saying is 351. Okay, so 1/2 base times height is the area of a triangle, and they're saying that's 351. So first of all, what's the base? The base I can go is from P to R, and the height I can say is the distance from the origin to Q, so OQ, I guess. Okay, so let's see what I can do here, what I can figure out. Well, OQ is probably the easiest, because that is just going to be the x-coordinate of Q. So that was line 2, right? So line 2, what was line 2? Line 2, the equation was y is equal to minus 2 over 3x plus k. And we are trying to get the x-coordinate, so when y is 0, correct? And I think we already did that. Yeah, it's right here. Okay, so that's easy, so that put that in there, 3 over 2k. Now PR is a little bit more trickier. PR, how do I get that? PR I think you can also get with this line. First I'll figure out OP, which would be when x is 0. So when x is 0, this becomes k. So that is k. And then I need from O to R. O to R. Then I'm going to have to use line 3. Okay, so I'm going to have to make that calculation. Line 3 is y. It has the same slope as L1, so it's going to be y is equal to 3 over 2x plus some b. But it passes through Q. So because it passes through Q, I can substitute in 3 over 2k 0, that point. So when I do, I get 3 over 2k plus b. So solving this, we'll get b is equal to minus 9 over 4k. And what are we interested in? We're interested in r. So this equation is basically y is equal to 3 over 2x minus 9 over 4k. And r would be when x is 0. So that would mean that y is equal to minus 9 over 4k. But we want the positive distance because it's a distance. So we'll put 9 over 4k here. And I believe that's pretty much it. And then you got to solve this. So let's do that. So put this over 1. So we got 1/2. So it'd be 4k plus 9k over 4. 3k over 2 is 351. And then now we have 1/2 13k over 4. 3k over 2. 351. And then, okay, this is going to be 39k squared. And that is 8, right? No, it's 16. 16. And then when you crunch out these numbers, you'll get k equals 12. The prime factorization of 324 is 2 times 2 times 3 times 3 times 3 times 3, or 2 to the power of 2 times 3 to the power of 4. Notice that 324 is a perfect square because it can be written in this form. The prime factorization of 63 is 3 squared times 7. Note that 63 is not a perfect square, but 63 times 7 is a perfect square because 63 times 7 can be written in this format. If the product 84 times k is a perfect square and k is a positive integer, what is the smallest possible value of k? So 84 times k is some perfect square m squared, right? Well, 84, the prime factorization is 2 to the power of 2 times 3 to the power of 1 times 7 to the power of 1, and then you got this k. Well, this is already a perfect square. In order to make the rest a perfect square, this k has to have at least a 3 in it and at least a 7 in it. Because if you do that, then this whole thing here would become 2 squared times 3 squared times 7 squared. And that can be written as 2 times 3 times 7 all squared. And that fits the appearance of an m squared. So k can be many things, but the smallest it can be is 3 times 7, which is 21. The product 572 times L is a perfect square if L is a positive integer less than 6,000. What is the greatest possible value of L? Okay, so similar but not the same type of question. So let's deal with this now. So 572 times L, and they're saying that's a perfect square. Okay, so let's break up 572 into its prime factors: 2 to the power of 2, 11 to the power of 1, and 13 to the power of 1. And then you got that L in there. And then L is less than 6,000. Okay, so, let me think about this for a second. Well, L has to have at least an 11 and at least a 13 in order to make this guy appear like a perfect square, right? Very similar to the previous part of this question. And 11 times 13 is what, 143? So L has to have at least 143 in it. But we want the greatest. Okay, so we don't want the smallest with this time. They want the greatest. Okay, so let's just see what is left over when I take that 143. I get about 41.95. So L is going to have that 11 to the power of 1, 13 to the power of 1. And then it's got to have something else that is less than that. That's a perfect square. Okay, I think I got it. And the smallest perfect, or the greatest perfect square less than 41 is 36, right? Yeah. Okay, I think that's it. So this would basically become 2 to the power of 2, 11 to the power of 1 times 13 to the power of 1. Then L is 11 to the power of 1, 13 to the power of 1. And I'm going to write 6 squared for 36. So this becomes 2 squared, 11 squared, 13 squared, and 6 squared. And that can be written as 2 times 11 times 13 times 6, all squared. And that is, of course, of the form m squared. Okay, so that's an interesting question. So what were the greatest possible value of L? I still haven't figured it out yet. 11 times 13 times 6 squared is 5148. And that is, of course, less than 6,000. So there you go. The list 10, 10, to the power of 3, 10 to the power of 5, all the way up to 10 to the power of 99 contains the 50 powers of 10 with odd integer exponents from 10 to the power of 1 to 10 to the power of 99 inclusive. Show that the sum of every choice of 3 different powers of 10 from this list is not a perfect square. So we've got all these guys, right? So we have 10 to the power of 1, 10 to the power of 3, 10 to the power of 5, and so on, all the way till 10 to the power of 99. So what they're saying is that if you take any of these 3 at random, so we don't know which one, so I'll just say one is called 10 to the power of A, one is called 10 to the power of B, and one is 10 to the power of C. And I don't know what is A, B, and C, but we'll just write them as A less than B less than C. Whatever we choose, we can just put them in that order. And they're saying that the sum, so that's going to be 10 to the power of A plus 10 to the power of B plus 10 to the power of C is not a perfect square. Okay, is not some perfect square. Okay, so we have to somehow prove that. All right, let's see what we can do. Well, the first thing I'm going to do is factor out a 10 to the power of A from this guy. So this will be 1. This will be 10 to the power of B minus A using exponent laws. And this will be 10 to the power of C minus A. Yeah, like that. Okay, so far no tricks, nothing. Okay, so what do we do now? Well, any power of 10 is going to be even, right? No matter what the exponent is, 10, 100, 1,000, 10,000, 1 million. So this guy here is even, and so is this guy. Correct? So that means this whole thing in the bracket, an even plus 1, would be odd. Correct? Yeah. And then, okay. I'm trying to think here. Now what do I do? I'm trying to show that that can't be n squared. Okay, now this 10 here, we got to deal with that. So let's just put this, we know this is odd. So I'm not going to write in what it is, but that's odd. And this 10, I'm going to break it up into 2 times 5. So we can do that with exponent laws, 2 to the power of A, 5 to the power of A. And we're trying to show that that can't be a perfect square. Okay, now recall that all of our exponents are odd and A is odd. Remember, it can only be 1 or 3 or 5 all the way up to 99. So that means, yeah, because the list only contains odd powers, right? So okay, I think I got it. In order for this to be a perfect square, this would have to become an even with something in here, right? Let me give you some numbers. Let's say A was 7, right? And there you had something like this. There would have to be at least a 2 to the power of 1 in order for these to match to become a 2 to the power of 8. And then that could be written as a perfect square. Forget about this 5. But you see what happened there? But since this is odd, this whole thing is odd, there is no power of 2 in here. So that's very important. Since this guy in the bracket is odd, it will not have a power of 2. It won't have something like that. So you could never match it with this guy to make it uneven and therefore a perfect square. Yeah, that's pretty much how it is. So you can explain that in words, and I think that should be sufficient. A Bauman string is a string of letters that satisfies the following 2 conditions. Each letter is from A, B, C, D, or E. No 2 adjacent letters are the same. For example, A, E, C, D, and B, D, C, E, C are Bauman strings of length 4 and 5, but A, B, B, C, and D, A, E, E, E are not. How many Bauman strings of length 5 are there in which the first letter and the last letter are both A? So we got 1, 2, 3, 4, 5, and the first and last letters are A. Okay. All right, so, I think we got to look at this from two possible categories. The first is where this is not an A, and the second is when that is an A. Okay, let's look at the first one. This could be B, C, D, or E. So we got 4 choices there, I believe. Yeah. Let's just say it's C. That means this could be, well, Actually, let me think about this for a second. Oh, boy. Oh, wait, hold on. I think we got to backtrack here. Yeah, and maybe look at this guy first. That is not an A, so the only choices are B, C, D, or E. Yeah, so there's 4 choices here. Yeah, so let's say it's C. This guy cannot be an A or a C, so it can be either just an A, it can be just a B, D, or E. So there's 3 choices for this guy. 3 choices here. And similarly, this one here, if this is C, it can only be a B, D, or E. So 3 choices here. So the total is 3 times 4 times 3, which is 9 times 4, which is 36. Okay, so 36 for that scenario. Now we looked at this scenario over here. This can be either a B, C, D, or E. So that's 4 choices. And similarly, this can be either B, C, D, or E, 4 choices. So 4 times 4, which is 16. So we got 16 here, we got 36 here. So total will be 52. So that takes care of part A. Part B, determine the number of Bauman strings of length 6 that contain more than one B. Determine the number of Bauman strings of length 6 that contain more than one B. Okay, so more than one B. So length 6, first of all. Let me just see what categories we have. More than one B obviously means either 2 Bs. How many Bs are there? It's either 2, 3, 4, 5, or 6. But remember, no 2 letters can be the same. So you can't have 6 Bs because that means all of them are the same. And I think the most you can have is 3, because as soon as you put in a 4th, you'd have adjacent that are the same, which would fail the criteria. So I think 3 is the most and 2 is another option. So these guys are gone. So really the only kind of scenarios I'm going to be looking at are 2 Bs and 3 Bs. Okay, so let's look at the 3 Bs first. So this is the 3 Bs. Strings with 3 Bs. So you can have either this kind of scenario. You can have this scenario where the B is at the end. And you can have this guy. Or you can have this guy where you just shift over one. And I think those are the only ones. Yeah. Okay, so I'm not going to go through every single one. I mean, you guys can get the hang of this. I'm just going to write out the possibilities. 4 choices here, 4 choices here, 4 choices here. So the total will be 4 times 4 times 4, which is 64. For this guy, it's 4 choices here, 4 choices here, but only 3 choices there. So that's 4 times 4 times 3, which is 48. And similarly, this is 48 and this is 64. So when you add up these guys, you get 224. Okay, so that takes care of the 3 Bs. That takes care of this guy. Now we just have to deal with the 2 Bs, but unfortunately there's a lot of those. So let me write them all out. Oh boy, here you got 1, 2, 3, 4, 5, 6. You have 2 Bs, so you have one scenario like this. Then you have another one where they're on the other side. And then you have where you shift over one, like that. Like this. Okay, so that takes care of 4. And then how many more do we need here? Well, all the way to the end there. Well, actually, not all the way to the end, almost to the end. Then we have that one. And then I think the next one is all the way to the end. So this guy. And then I think there's a couple more in the middle like this. And then this one where you put them in the middle like this. Yeah. And this one. Yeah. Let me just see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9. I think that's it. And then I'm just going to do a couple. There's 4 choices here, 4 choices here, 3 choices here, and 3 choices here. So that's going to be 144. And very similarly, that's 144. And this is 144. Like I said, I'll let you guys do the calculations because it's very similar. And let me see here. Let me just, before I write them out, let me just double check. This one here, I might have to talk you through this one. 4 choices here, 3 choices, 3 choices, 3 choices. So that's going to be 108 actually. And this one is 4, 4, 3, and 4. That's 192. And this is 4, 4, 4, and 3. So that is 192. And this is 4, 4. Well, hold on 1 second. The 2 B's. That's also 192, yeah. So you have how many of these guys do we have? Oh, I forgot this one here. The ones with this one here. I believe that one is also 144. Okay, so we got 6 of these 144s. And then we have 3 of the 192s. And then you have 1 108. And that all adds up to 1548. So we then grand total this guy and this guy. And that grand total of 224 plus 1548 is 1772.